So chapter 8 starts out with, and here's this word static. And some folks don't take 161 and 162, so they don't see it in another way. And it's very similar. But we're going to take a look at some static members. There's two members, right? There's fields and there's methods. So in a static field, and I think this note really helps it make sense. And then when we look at the code listings in a minute, hopefully it's definitely clear. But only one copy of the field is in memory. Okay, there's not multiple copies of the field for multiple objects that could be created. Okay, and it's shared by all of the objects created, all the instances of the class. So if I make 5 objects, this static field is the same for all of them. It doesn't get changed. And when you did code listing 8.1, you had this static field. And how do I know it's a static field? Because we can't see it. There it is. How do I know it's a static field? Right there. Has the keyword static in front of it. So this static now gives us a whole different meaning when we start digging into methods and classes and other things. So I have this static variable instant count. So when I come in to this class, I see that, let me back up. When I call, we're going back to all of our class lingo. When I call a constructor, this looks like it's the default constructor because there's no parameter list there. I call the default constructor, and when I do, all I'm doing is adding 1 to that static variable. And then I have a method called getInstantCount, which will tell me what the value of that static field is. Okay, doesn't get reset, rechanged, anything. It's the same one for every single object. So when you typed in 8.2 and did the demo for this, you notice you instantiate. I need to put this up a little higher. Is that still seeable? You instantiate 3 different objects here. Object 1, it calls a default constructor and hits that static variable and adds 1 to it. I create another object, adds another one. I create another object, add another one. And then finally, I want to call a method that's in that class. I just happen to do it on object 1. I could have done it on object 2 or object 3 or any of the objects, returns that value and displays it. And as you can see, 3 instances of the class were created. Okay, so that's what's known as a static field. And again, that might be something that, you know, it's one of those, it doesn't seem very common, but it's something we can tuck away and you never know when it's going to get used. Second part of section 8.1 is a static method. And all of a sudden I'm down here and I'm writing math class. A static method is one that's just like we saw in the math class. I didn't need to call the method on a particular object. I used the class name, math.squareroot, math.pound. So I didn't need an object to get to it. I was able to get to it just by the method name. So static method, again, it isn't necessary for an instance or particular object of the class to be created to execute it. And we had an example of that in code listing 8.3. You typed up this static double kilometer to miles inside of this class. So now I have a static double miles to kilometer, a static double kilometers to miles. So both of these are now available for me to use. I don't know why I don't have that one highlighted. So static method, that means all I have to do is use the class name, like right here. The class is metric. I can use the method that's in there. I have an argument I'm sending over to the parameter list. The calculation gets done and it gets returned. Not so bad. That word static has been around for a while. We didn't really know what it meant. Questions on 8.1. All right, not hearing any. Let's take a look at section 8.2. This is one of those things where, oh my goodness, once we learned about methods, every time we learned about a new data type of sorts, we talked about passing it to methods and returning it from methods. And if you think back to methods, you know, early on we did ints and doubles and chars, and we talked about how strings work. And then we got into arrays and we passed arrays. Some of you are dangerous because you had 161 and 162. And in C++, we talked about passing by reference. And in essence, we're going to keep that idea in mind of what it means to pass by reference. Because like we did with arrays, we passed in the array name. And remember, if I said int, I'll mess this up, array1 equals new int, and on and on and on. If I use just the word array1, that was a what? Versus array1 sub 2.
Array1 is a reference to the first element in the array.
Really, really, really close. You could kind of almost say that. So what you're saying is this is the same as this. And the answer is no, so close.
What's a pointer, basically, and it points to that first position.
What does this hold? Two words.
Address.
Memory address, right? Yeah. This holds the memory address. Okay. This is the first whatever. Oh, this is the first byte, 4 bytes at that memory address. So it's really close, but this is a memory address. And this is what we were passing in because it would go in and yeah, we were all happy then because I could fill an array or do different things with an array. Well, just like everything else, I can pass an object in. Okay. And when I pass it in, I'm going to pass it as reference just the same. When I return it, I'm going to return it as reference just the same. So that means I'm just going to be passing in the names and taking a look. I believe you had code listing 8.6. No, you did not. So we're just going to take a look at it. I come in and line 11, you see I'm creating an object rectangle. This guy loves rectangle. He uses rectangle a lot in this course. Okay, it's called box. I come down here and I'm calling a method. Looks like a void method, change rectangle. I'm sending in box, which is the address. Because remember, once I'm there, there's going to be a couple different fields and things to work with. Then I come down from here to there, and here we go. Change rectangle, it comes in. Here's now my parameter list because I passed in an object of called box of type rectangle. Here I'm calling it R. Here I'm giving new values. So I'm able to pass them in. Again, it's starting to be one of those repetitive things. Every time we learn something new, we talk about passing it into a method and returning to a method. And just like arrays, we don't really have to know how to return them as well, because this would take care of it, passing it as a reference. But there may be a time where you say, hey, well, I want to, call something to get it up and going, and I want to return something of type bank account in this case, but I want to return an object and store it. Just like everything else we did, the syntax is the same. When I come over here, I see I am getting some information. I want to know what the balance is to start. Okay, up above, public static bank account. That's my return type. When I call get account, when I return it, you notice they're being really clever and they're returning, instantiating a new object. So they're creating a new object with the address and so on, sending balance in as a beginning value, and it'll store it back up in the main where this method was called. All right.
For that, just a quick question. They just didn't have a parameter argument for that one. So they had
Well,
to create one in the method.
okay, so when I'm returning, and so instead of having a line up above that instantiates the object and then returning bank account, or bank or whatever I want to call it, it does that all at once. It creates the address and sets it all up, and then it'll store it. So they
Oh,
really,
okay, it's a static. I got it. Okay.
yeah, they shortcutted several lines here. And, once in a while, I'm okay with them doing that, just to show that you can be creative and do some of those things. But instead of instantiating a new object and so on, and then returning that object name, they just did it in one line. Good question. Two-string. Let's see if I wrote anything down on my notes about a two-string. Two-string. Those of you who had me for 121, and I think it's almost everyone, two-string used to be earlier in the book, and I like two-string. In chapter 6, in chapter 6, when we talked about methods, this was included. Now it's yanked out and put here at the end. But a two-string is a method. It has the name two-string. That's the name of the method. And it's going to return a string that you can build, that when you go to display your object's name, it'll display it. Okay. Let's see what's going on. Ba-da-ba-ba-ba. So I have a class from the previous page. This is code listing 8.8. This class is called stock.java. And the very last thing in the class is my two-string. Two-string has a return type of string. It's me building a giant string with all of the information I want to display from the class. The class had two fields. One was called symbol, one was called share price. I could have put a lot of other things in here. And those of you that had me in 121, you really could have bulked this up and had 10 lines, but I'm going to return that string. Now, what happens is when I get ready to, let's see, I create an object called XYZ company. And when I get ready to display that object, it's going to give me all of the information from my two-string. I don't have to use the name two-string, which is the name of the method or anything. It automatically knows to do it. So what's going to happen is we created a class for this problem, but there's a class up above here, another class that we don't see. And things in this class are written. There's a bunch of methods that are written. And this is stuff that's coming up. It's called inheritance. And when I write a class, I inherit some things from up above. One of the things that's automatically inherited is the method two-string. So when we do a two-string in our class, it overrides the two-string from above. Well, the two-string from above up here is kind of goofy, because if before you would have tried to print out an object name, you would have gotten a bunch of little crap, and it would have been like a memory address and something else. So if we didn't overwrite that two-string and we tried to print an object, we got stuff we didn't like. So eventually, this whole object-oriented programming, which we're kind of back into again with classes, we're going to start talking about how this class, and I'd write it as a UML chart, would inherit everything from this secret class up above. Okay. Any questions on the toString? And again, I wrote the question in, what if we display an object without a toString in the class? It goes back to that default and something goofy kind of prints out. Whew. That's a lot of noise from me so far. How are we making out? So far, so good?
Yep.
Okay, I will keep going. We covered 4 sections, but if you start thinking about it, static's kind of the only new thing. And hopefully you picked up quick on that. Passing and returning objects, conceptually, you knew it would happen because it was so similar to arrays. And toStrings we kind of got into before. Okay, the next thing, as you can see, this is section 8.5. And I want to know, is it possible to see if one object is equal to another? So if R1 is an object out of rectangle class, R2 is out of rectangle class, can I say if R1 equals R2? Can I say that?
No, wouldn't it like compare like the addresses or something?
So yeah, you kind of answered it right. It's a yes and a no. Yes, I can do this. It compares the addresses, but that's probably not what I want to do. Okay, I probably want to see if all of the fields in R1 are equal to all of the fields in R2. And that brings in 2 words of the whole shallow and deep. Okay, shallow would be I'm comparing the addresses. Deep would be going down and looking at all the fields. So if I wanted to get ready and include in my UML chart, in my class, a method that would allow me to compare 2 objects of that class, I would need to write something called an equals method. Okay, and equals is kind, you could call it anything you want, but equals is kind of a standard, and I'm going to strongly recommend you do that. Okay, so if you take a look at it, again, we need to write a method. Interesting note here, the return type should be Boolean. Well, yeah, okay, that makes sense. Would have gotten there. Doesn't hurt to know it now. Okay, so public Boolean equals. I have a parameter that is going to be an object of that type. So now inside of this equals, I could say, my current one dot is equal to blah, 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 and blah, blah, blah. So length equal to R2 length and width equal to R2 width. And if both of those are true, I could return a true for this method. Should I say that again? I kind of stumbled there and tried to say it a little bit better as I went. I would be doing something like length, because that would be the length of my calling class, equals R2 dot length. And, I'm not sure if I could use that or if I'd have to use a get length. I may have to throw in a get length to get it to compare it. But you got the idea of what's going on. So this would be part of an if statement. If that's true and the widths are true, then I would return, or equal, then I would return true. Otherwise, I would return false. So this guy right here is the one of the object that called that method. In this case, R1. So this is R1's length. Now, in the old days, inside of here, we used to have to put the name this. And we would say this dot length. And it has kind of gone away, but it's going to get mentioned here in a moment, because sometimes I may bring in a parameter and have it as the same name. I could have it as length. So when I say this dot length, it knows that it's R1's dot length. And like I said, back in the day, we used to have to include the this dot in front of all of our field names to help us remember exactly which one it is. So again, if I would have had a parameter in here, int length, which I can, because it would be a local one, and then I would put length here. This is how I would distinguish between the two. This. All right, so that's an equal method, equals method. Some of you are going, when will we ever get to type something? I know, right? Well, in a little bit, I'm going to have you do a circle class. And one of the things I'm going to include in this UML chart for a circle class is an equals. So in a little bit, you're actually going to get to doing the equals. Section 8.6, 8.6. We're almost there. 8.6. So I just talked about comparing two methods to see if they were equals. And we looked at bringing in an object into my parameter list, which is what we had talked about back in section 8.2. So we've really reiterated what we learned earlier. But I want to make a copy of an object, and I'm going to show you two different ways to do it. The first one is to create a copy method. The second one is to have a copy constructor. Now, when I make a copy, remember, I don't want that shallow, one gets the value of the other, because it would just be passing the address like here. No, that should be in red under no. I can't say R1 gets the value of R2 unless I want to copy their addresses over. Okay. Instead, I would write a copy method. And you notice the way this is laid out, where I call R1.copy. Inside of there, I would create a new object and copy the fields over, and then I would return that new object so that I could store it in R2. Now, again, somebody might be saying, could you also have done something like R2 and wrote a copy a little bit different that passed R1 in? And, so are there other ways to do it? Yes. But what we need to do is make sure that we do that deep copying in there. Copy length to length, copy width to width. Here's a quickie example. Where is it? Well, where is my hairbrush? There it is. Up here, out of the textbook. Public stock copy. I come in, I create a new object, and oh, it looks like they're taking advantage of the current one symbol. It looks like they're taking advantage of a constructor here. They're calling the constructor to create the new one. That's one way. Copying field by field would be another way. So one way is a copy method. The second way, as I mentioned, was a copy constructor. And as you can see, I'm creating a constructor of class stock. I'm bringing in my parameter list, object 2, which is of class stock. Okay, so far, so good. I take the symbol from object 2 and I put it into the symbol of my current class. So this guy is taking another class and updating my current class. And again, I update the share price of my current class. So I'm creating a copy constructor. I'm bringing in another class, and then I'm stealing its values in my constructor when I'm creating a new object. Okay, so that's the copy method. And again, here's an example of the copy constructor. The object coming in, its length goes to length, its width goes to width of the current class. And again, I could have put this dot length and this dot width just to make sure there isn't any confusion. It would know to go to that of the current class.
I have a question.
Yep,
So the toString and the equals methods were both inherited methods, but the copy one is not. Is that right?
that is correct. That is correct. Yep. Because we can use equals, it just does the address comparison, believe it or not, as well as the equal sign. Okay, again, a lot of material. Doesn't seem too tough, but then we also have to get ready to take a look at it. All right, aggravation, excuse me, this is aggravating. Aggregation. Your next program, I'm going to post it shortly, deals with aggregation. Okay, so aggregation, this is something I'm going to jump off of here and go into here. And I'm going to say it this way. So I have a class called Constructor. Right? There we go. I have a class called Instructor. And in this Instructor class, you see last name, first name, and office number. That's good. That's kind of all I really need to get started. I have inside of here, we're going back to Uml Chart. The class is Instructor. This has to be a constructor. This has to be a constructor. So two different constructors, two different parameter lists, two different signatures. Parameter lists were also called signatures. I have a set and a toString. Not much in that class, but I have a class called Instructor. And we can go through and holy pololi, now you know why I didn't have you type this one in. It's here's my first constructor, here's my second constructor, here's set, and then here's another example of a toString. And we're going to start to want to write nice toStrings. I'm just forewarning you because we're going to be able to build on toStrings. You're going like, what? Okay, so my next class is called Textbook. It has a title, has an author, and it has a publisher. So I could get ready and write this class. It's called Textbook. Has two constructors. There's another set, and there's another toString. And if you're following along in the chapter 8, code listing 813 is all of this about a textbook. So now I have a class instructor and I have a class textbook. Bam! Check out this UML chart. I have a class called course. I have a field called course name. Its data type is string. I have a field called instructor. That's a type, that's an object I'm instantiating of the instructor class. Textbook, that's an object I'm constructing of the textbook class. This is what's called aggregation. And that's what your next program is going to do. You're going to have a class who has a couple of fields that are from other classes that you will create. And it's called aggregation.
Quick question.
Yep.
So I think this is a gap in my Java knowledge, but I've noticed like if you're including something from another class, it doesn't seem like you have to import it like you did with C++. You don't have to include the class. It just seems to kind of, if it's in the same file location, it compiles. Is that correct or?
That is correct.
Okay.
Yes. Yep. Yeah, I can see where you have the crossover confusion with C++ to here, especially when you just did header files and implementation files and tying all that together.
Yeah,
All right, so let's see what's going on in here. Here's my program. I have, yeah, that's what I said. I have an object from the instructor class. I have an object called textbook from the textbook class. And I just, oh boy, I come in and course name, I fill the first one, and then work that's already done for me. I'm taking care of my second field, instructor. I'm taking care of my third field, textbook, because I'm calling things from, let me rephrase that. In this constructor, I'm calling constructors of other classes. There, I think I said that a little better. And again, this is a constructor where the name and some other things are being passed in. This could get kind of deep here. What do we have going on here? Get name, return course name. I got that. That's not so bad. Get instructor. I'm returning information from my instructor class. Get textbook. Here's what's cool at the end. We'll be doing more of this later. Public string, toString, course name, which is course name from above, instructor information. And guess what this instructor right here, what's that getting for me? When I say instructor, what is being pulled in?
The toString method for instructor.
Excellent. The toString method from instructor, and again, the same thing's going to happen with textbook. The toString from the textbook class. So these are written well on top of adding those to a third one should come out really nice. And we have a course demo, and here we go. Here's the course name, and then the information from the constructor for the instructor is there. And then the toString for the textbook is all of that information. And now we take a look at the UML chart. Okay, the diamond. It's the way to show aggregation. The next chapter we get into, we'll start looking at more and more different drawings of how different classes are related to each other by showing their UML charts. But here we go. Instructor, instructor, textbook, textbook. And if I said, hey, yeah, I want you to write, and I handed you the UML chart, you're rubbing your hands a little bit saying, okay, that's a lot of pre-thinking that once that's done, it's going to make the typing a lot easier. And that concept is one that's stressed over and over in CPS 162. Do a lot of pre-work because it's going to make your regular work first. And one student in this class with their border pane program actually included a drawing that they did and how they wanted to lay everything out before they started so that they didn't just start pushing keys and go nowhere. They had direction of what to do. Just like the last program, somebody had other test data other than what I gave you. I think Matthew was the one that did the layout for the last program. And I think that was you, Japheth, that had other test data to make sure you understood what's going on. And more as you move on in programming classes, you need to start thinking about direction. It's more about thinking than it is just about typing. And if you Google that statement, you'll see t-shirts on the interweb and so on that say programming is thinking, not typing, because there's a lot that's going to go into it. Okay, aggregation. Aggregation. And again, one of the things we need to be careful of with aggregation is this shallow copying. Okay, and that's the one where you're just copying a reference, copying the address versus deep copying. And as we move on through the course, you're going to see this concept comes up quite a bit, the shallow and the deep. All right, folks, hang in there. To this reference, this for my reference variable, again, I can say symbol, right? Because that's a field in my class, and I'm bringing in sim and I assign it. I'm bringing in price and I'm assigning it. You know, these are two new local variables. But what if I wanted to bring in the word symbol and share price, which are my fields that I already have? Well, this is called shadowing. I can make sure I'm referring to the symbol that's in the current class by including the word this in front, and the share price in the current class by including this in front of it. Now this. Okay. The last section, I don't know why they still bring this section up, but it's brought up. It's called an enumerated data type. And you see this in this class and you see this in one of our other classes, but I need to include it in this one in case people just want the entire book of Java. So I'm going to create a new data type. Okay, there's that phrase again, data type. A type, a way to store data. And this one's called enumerated. And they say it makes your programs more readable because we are going to name numbers. We're going to give 0 a name. Instead of 0, we're going to call it Sunday. So I'm going to create a new data type by using the word enum. The data type, its name is day. And when I create a variable of type day, it can hold the value Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, or Saturday in all caps. You notice these aren't in double quotes. Okay. Sunday gets the value of 0. Monday's value would be 1, Tuesday 2, all the way out through Saturday being 6. Another example of an enumerated data type, believe it or not, would be this. So we can think in terms of Boolean as being an enumerated data type. False stands for 0. True stands for 1. Data types of this type are called ordinal data type. And back when we were doing switches, I made mention that you have to have an ordinal data type. That's one that has a predecessor and a successor. Predecessor is something that comes before it. What comes before false? I wrap all the way around to true. What comes after false? True. If I looked at int, what comes after 3? 4. What comes before 3? 2. Chars are the same way. Strings are not. Doubles are not. Okay. So all of these have a number. All right, so I can go through and I'm going to take a look at a little bit of stuff here in the book, and just give me a code listing. That's all I need. So here's a code listing. I created an enumerated data type day, which is the one that I was just showing you a little while ago. Down in here, I create a variable called workday of type day, and I'm giving it the value Wednesday. So really, it's holding the value 0, 1, 2, 3. And then there's things I can do with it. The ordinal value for day Sunday should be 0, and so forth. And as you look over here, the ordinal value for Sunday is 0. The ordinal value for Saturday is 6. Friday is greater than Monday because it's looking at that numerical value. Questions on enumerated data type? Guess what happens when you throw your book back and forth on top of your keyboard? Yeah. Help me out. Look at the following statement. Enumerated data type flower contains rose, daisy, petunia. What is the name of the data type?
Flower.
What is the ordinal value of rose?
0.
What is the fully qualified name of enum constant rose? What? Again, we don't need to get into all kinds of stuff, but we can give names to numbers. Here's another one, creatures, a hobbit, an elf, and a dragon. I would hate to see what happens next. We have some different things going on there. Print them out. Creatures.hobbit would print out the word hobbit. Creatures.elf would print out the word elf. Here's another example where I can compare the numbers. So as you can see, I'm not too overly wound up about the ever popular enumerated data type. Can we finally type something? Yes, you can. But before we leave, or before you get started, do you have questions on chapter 8? As I said, aggregation is going to be your next program. Yes. Say that again. Nope. Can you hear me? I'm back. Can you hear me? Bueller? Okay, good. All right. As I said, aggregation is a big thing out of chapter 8, and that's what you're going to be working on for your next program. And we're going to talk a little bit more the rest of today about the equals and the copy. But anything we covered today will be on the test next Tuesday. Next Tuesday, you're just going to sign in like this. I will give you a password and you will be able to take your exam. And that's all we will be doing that day. So let's take a look at what I want you to do now. I want you to write a class called Circle. There may be some of you who look back through your old CPS 121 stuff and you'll go, oh my gosh, I already have a lot of Circle done. Not only do I have some of the class done, I have a demo program for it. And if you do, that's great. But here's what I want you to do. I want you to add a couple of things. First one is the equals method. The second one is the copy method. The third is a copy constructor. And if you don't have it there already, a toString. And again, if you don't have the class, starting from scratch isn't really a bad idea. Up here, I have one field called radius. Should I have a field called circumference? I see one head shake no. Somebody tell me why I wouldn't have a field called circumference. It would.
You can get stale data to change.
Stale data, right. It could create stale data because I may have a value for circumference and then go and change radius and forget to update circumference, and that could be incorrect. So we don't want to have any extra variables that we don't need because it could create that stale data.